we're going to start. So make sure you're ready for us
Yes,
to
teacher.
start.
Mm.
Okay. So today we'll be looking at chemistry. All right, who can remind us on what we looked at last time? Who remembers what we looked at last time in chemistry? Raise up your hand. Who remembers what we looked at? Anyone? You all forgot? Who can remember? Yes, Adonai. Adonai, we can't hear you. Adonai, I didn't hear you at all. I don't know if the rest heard you. Who else would love to try? Who would love to try? Claire, do you remember
Sorry,
what
teacher,
we
my
Daniel, do you remember? Sanyu, we're trying to remember what we looked at last time. So if you remember, you can raise your hand and tell us. Yes, Kyle.
we looked at matter and the
Matter.
different states of matter.
Yes, we looked at the different states of matter. And we also looked at the properties of matter. So today we shall investigate further to see exactly how those properties work. Okay, how those properties work and how we can always investigate them. Is what we shall concentrate on today. Okay, again, this lesson is brought to you by Yaka Digital Network. Remember, this is your last free chemistry lesson, so please make sure you encourage your parents to subscribe to Yaka so that you continue learning with us. It's very, very important for you to continue learning. Remember, for us, we offer these lessons throughout the year. If you subscribe for a year, it doesn't matter whether you go to the next class or not, we shall always conduct these lessons for you. If, for example, you guys go to senior 2 and your year that you subscribed is still on, we still conduct lessons for you in senior 2 until your year that you subscribed for ends. When you're at school and you can access a computer lab, you can always access our website and get work and things like that. When you come back in the holiday, we teach you, we give you activities and so many other things for you to utilize. Okay. So encourage your parents to make sure that you are subscribed to Yaka. Please, when you join, mute your volume. I am trying to mute these people, but they are unmuting. Okay. So today we shall be looking at the investigation of properties of solids, liquids, and gases. That's what we shall concentrate on, seeing exactly what makes these solids and liquids and gases look the way they do. So the properties of substances depend on how particles in these substances are arranged and how they are held together. So the property of a solid will be determined on how its particles are arranged, okay, but also how they are held together. For example, in this lattice or in this structure, the way they are arranged will determine how this particular solid behaves. Same as this liquid, okay? The arrangement and how these particles are held together, the forces between them, will always determine their character or their properties. Same as the gases. The forces between them, okay? For example, between this particle and this one, plus how just randomly the particles are, will always determine how this gas will behave. So that's what we mean here, that the arrangement and the forces between the particles determine how a particular substance shall behave. Okay, so those are those are the two factors that will determine the properties of a substance. Okay. So I have a question for you here. As we can see, these are the particles of a gas. These are for the liquid and for a solid. But the question is, why is it that it is easier to run fast on land than it is to swim fast? Why is it easier to run very fast on land than it is to swim very fast? Who can tell us the reasoning behind that? Why is it easier to run on land than to swim very fast? What do you think is the reason behind? Who can try? Why is it so hard to swim than it is to run on land? Why is it hard to swim in water than it is to run on land? Who can tell us what is the reasoning behind? What do you think? You can always try. You don't have to give the right answer. Let me see. Betty? Yes, Betty? Betty, unmute your audio and speak. You unmuted your video instead. Unmute your audio. Now you can speak. Unmute and speak. Okay, as Betty figures that out, let's have Jacob. Yes, Jacob. What do you think? You also have to unmute and speak.
It's because the forces holding water particles are much greater than the forces which hold air particles together.
Okay, very good. That is excellent. The forces that hold water particles are stronger than the forces that hold air particles together. Very good. Onen, do you have a different answer? Onen, do you have a different answer? Your hand is still up.
Yes.
Okay.
So for liquid, the the line where you're meant to swim for liquid, like the molecules. Okay, the molecules are partly spaced, meaning you have more obstacles in front of you. And as for solids, like the particles are all fixed in one place. That is the land for solids.
Yeah.
So meaning you have greater, you have less particles. The particles that you have are the gas molecules.
Okay, that's good also. Yes, Naomi? Naomi? Okay, Naomi cannot unmute. All right, so that is very true.
Because of the lack of adoption.
What do you mean by the term adoption?
Like swimmers first, yeah?
Unen is saying the teacher is not allowing participants to unmute. No, you're failing to unmute. Me, I only muted you once when you had your audio on. So make sure you can unmute.
Okay.
All right. So yes, I was saying that it is true. Jacob was correct when he said that the forces. Oh, who is writing here? The forces. The forces of attraction between particles of gases. Okay, the forces that between these particles in gas molecules, right, are weaker, okay, than the forces of attraction between liquid molecules. This means that a person who is swimming is going to face a lot of resistance due to the fact that the particles have strong forces between them. So the swimmer faces a lot of resistance. That's why they are slow. But the one who is just running on land, the only resistance is facing is for the particles between, for the forces between the gas particles, which we have understood that they are very, very weak forces, okay? Very weak. So the runner runs through smoothly. But the one who is swimming in a liquid is gonna face a lot of resistance due to the strong forces between the liquid particles. So that's the explanation, okay? So well done, Jacob. That was good. All right. Okay, good job. Very good. So far, we understand now that gases have stronger forces of attraction between them than the liquids. Gases have weaker forces between them than the liquids. Okay? The liquids have stronger forces. All right, now, before we even go further, today we have a very good attendance. We have about 45 of you. And some of you, that means did not attend yesterday. So what I'm going to ask is that write your name and contact in the chat box, okay? As we continue, type your name there and your phone number. It is important that you do that as we continue. So start now, write your name and your phone number as we continue. Okay? All right. So let's start on the investigation of the particles in solids. All right? Who can tell me the nature? You can also use this diagram here that you're seeing. This is a 3D model showing the arrangement of particles in solids, okay? Now, who can tell me the properties that particles of a solid show? Okay, you can also use this model here. How do the particles in a solid behave? Yes, Isaac?
Particles of the solid are tightly packed together.
Okay, one, they're tightly packed together. That is good, Isaac. What else? You can tell me something else? Ronald. Ronald, you had your hand up. Okay, Mary.
The particles have strong intermolecular forces of attraction.
Okay, the particles of solids have very strong intermolecular forces of attraction. That is also correct. Ronald, do you still have your answer?
Solids are made up of tiny particles which are closely packed together.
Yes, they're closely packed together. Who else would love to give a different answer about these solids? Yes, Betty?
Particles in solids can vibrate but cannot move past each other.
Okay, particles of a solid vibrate in a fixed position. That's what you mean, right?
Yes.
Okay, good. That's very, very good. Miracle?
Particles in solids are not compressible.
Particles of a solid are not compressible. They are hard to compress, okay? Let's just say they are hard to compress. That's good. Onen?
The particles in solids have infinite volume.
Have a what? Fixed volume?
Fixed volume.
That is true. They make a fixed volume. Jerome? Yes, Jerome?
Me?
Okay. Yes?
In solids, particles have strong intermolecular forces of attraction.
Strong intermolecular forces of attraction. That is very correct. I saw Claire's hand. Yes, Claire?
Particles in solids are orderly arranged.
Okay, they are orderly arranged. Very good. I've all given very good properties of particles in solids. That's good. Keep it up, okay? All right. Let's get explanation sorry, of each. So the particles in solids are very close to one another and are in fixed positions. As you can see in this illustration, these particles are very close. We have two types of particles here, the green ones and the blue ones, all right? But as you can see, they are closely packed. There are hardly any spaces in these particles. The spaces are there, but they are so small, so small. Okay, so they are closely packed, and they are always in fixed positions, as you can see here. Okay, so it's important to know that. The other one is the forces of attraction between particles are strong, like you guys said. That is very true. It is one of the reasons why they are in fixed positions and they are strongly held together. They have strong forces of attraction. Okay, so the forces between each particle are so strong, right? They are so strong, and that's one of the reasons why they are held together, they are in a fixed position, and all that. Okay. The other one is the particles can vibrate but cannot move past each other. You guys mentioned that too. So these particles can vibrate. It's one of the reasons most solids can transmit sound, they can transmit electricity or heat, because they can vibrate. But when they vibrate, they do not flow, they are in fixed position. Okay. Please mute your volume before I mute you. So they vibrate in fixed positions. Okay. It's important for us to remember that too. They're not like water that they're going to flow or any other thing like gases, how the particles move. These ones, they're just vibrating in fixed positions. Okay. No movement whatsoever in terms of change in position. They only move by vibration. And the other one is that they are close together, touching each other. So as you can see in the 3D structure here, they are exactly touching each other. The forces hold them so close to each other that they are touching. Okay. Now, depending on the shape, you'll see that even though they're touching each other, there will still be some small spaces in between them that are very, very minute, meaning very, very small. Okay, which is very important. So those are the particles of solids. That's how they behave. Those are the properties. Okay, I would like to remind you to write your names and contacts in the chat box, just like others are doing. Please remember to do that as we continue. So any questions about these properties of solids? Questions? Any questions? Something you have not understood or something you need more explanation on? Yes, Betty, your hand is up. I don't know if you forgot it up or you have a question. Okay, it's down now, so probably you had forgotten it up. Any questions? Something you've not understood? Yes, Ronald? Ronald?
Are they made up of tiny particles? Are they made of tiny particles? Are they made of tiny particles?
Are they made of tiny particles? Who can answer that? Who'd love to answer that? Question is, are solid particles made up of tiny particles? Yes, Betty? Betty, we can't hear you.
They are made of tiny particles.
Okay, yes, they are made up of tiny particles, Ronald. They're very tiny that your eyes can't even see them. We have to use a microscope to see them. Okay. Any other questions? Okay, good. We can continue.
No, teacher.
Okay, let's continue. So we have here particles in a liquid. Okay, particles in liquids. Who is going to describe for us some of the properties of particles in liquids? Here is a picture to give you hints on how liquids behave. You can use this 3D picture to come up with ideas on how liquids behave or particles of liquids behave. I want someone who has not said something. Yes, Kyle?
Yes, the particles in liquids do not touch each other as much as the particles in solids. That's because they have space in between each particle.
Okay, that's good. They don't touch each other like in solids. Yeah. Yes, Joyce? Joyce?
Particles in
The rate of diffusion in liquids is low.
Joyce giving her answer. I don't know who is that talking. I think Joyce, please raise up your hand if you want to say something. Joyce, your network is not good. Find a place where there is network, Joyce. Okay, let's have Ntambi Joshua.
Teacher, particles in liquids have moderate.
particles in liquids have relative molecules.
I'm going to pick someone to say something, okay? Don't say something when your hand is not up and when I've not picked you. Yes, Hannah?
Particles in liquids are relatively spread apart.
Okay, they are relatively spread apart. That is correct. Yes, Valerie?
Particles in liquids can make relative motion.
Okay, they are in motion relatively. That is correct. Irene? Yes, Irene? Okay, Irene can't unmute. Miracle, what do you have to say?
The particles are mobile within the definite boundary.
Okay, they are mobile within a definite boundary, depending on what they are contained in. That is correct. That's very good. Lastly, Jerome. Yes, Jerome. Jerome, can you hear us? You can unmute and speak. I can't tell who has unmuted themselves. Yeah, okay. Naomi, mute your sound. I'll mute you. Okay, Jerome can't hear us. So you're all very correct. The forces of attraction between these liquid molecules are not as strong as those in solids. For these liquid molecules, they can move around, all right, within a definite boundary where they are. As you can see, this structure is showing you that they can move, okay, in different directions, mostly in the same direction. They'll hardly move in different directions. They're mostly in the similar direction. So let's look at some of these properties in detail. So the properties in liquids vibrate, but can also move past each other. Okay, so they can slide over each other. They are capable of sliding over each other, which we have not seen in solids. The other thing is they are closely together, touching each other as in a solid. However, the forces of attraction between the particles are not as strong as in solids. So some of these are also touching each other, but they are not, the forces of attraction are not as strong as those in solids, like we have seen. And this is the reason why they can even slide over each other, because the forces of attraction are not that strong to hold them in the same position. The weak attraction between them cannot support particles in one position. So solids take up the shape, so liquids take up the shape of the container. So unlike in solids where you have a solid having a definite volume and shape, right? In liquids, there's nothing like that. They don't have a definite shape. They always take up a shape of the container in which they are. If you put water in the cup, it will have the shape of the cup. Once you transfer that water in a jerry can, it will have the shape of the jerry can. And once you transfer from the jerry can to the saucepan, still the water will take up the shape of the saucepan. Okay, this is all because they have weak attraction between the molecules. Okay, that is the explanation. Any questions here? Any questions on liquids?
No, teacher.
Yes, Miracle, you have a question? Your hand is up. Miracle, your hand is up. Do you have a question? Onen, do you have a question?
Yes,
No.
teacher.
Okay, ask.
Teacher, when liquids change, okay, no, when liquids like turn into like vapor, do we still call them do we still call vapor a liquid state, or we say gaseous state?
Okay, that is a very good question. And then who would love to answer that? And then is asking, once a liquid turns into vapor, should we say it is still liquid or it has turned into gaseous phase? Who would love to give us an answer? I'd love to see someone who has not said something. Someone who has not said something. Laura, today you're quiet. Say something.
I think when a liquid turns into a gas, it turns into water vapor, it's a gas.
Okay, very correct. So once a liquid turns into water vapor, it has changed a phase, okay? It has gone from liquid to a gaseous phase, all right? So we can't say that that vapor is still a liquid. We say, now that's a gas, okay? It's turned into a gas. It's a different phase, all right? So from liquid phase to gaseous phase, okay? So I hope that answers your name.
Yes.
Okay, good job. All right, so I also want to remind you again to type in your name and contact in the chat box. For you who have not yet, just follow your friend's lead. They have already done that. You also do the same. Let's look at the solid, the gaseous particles. Who can describe for us the behavior or the properties of gases? You can use this picture to describe. Again, people are quiet. Please raise up your hands. I don't want the same people to keep raising. Yes, Claire?
The particles of gas are far apart.
The particles of a
far.
gas, they are very far apart. That is correct. Naomi. If Naomi is not speaking, let's have Nadia.
In gas particles, there are continuous straight line motions.
Okay, in gas particles, they are continuous motion.
Straight line motion.
Straight line motions, that is correct. Okay, Nadia.
If squeezed in a closed.
Yes.
If the gas particles are squeezed in a closed container, they move closer together.
Yes, if gas particles are squeezed in a container, they will move close together. That is correct. Let us.
They are freely spaced.
They are freely spaced. That is good. Okay. Who else has not said something?
They move quickly in all directions.
They move quickly in all directions. That is awesome. Yes, Valerie?
They are not held by any force of attraction. They are not held by any force of attraction.
Okay. Good job, everyone. Those are great answers. So that is how gases behave. They move freely in straight line motions. They are continuous. They are always in a continuous random motion. Okay. They are spaced apart. The molecules can be squeezed together or compressed together. Once put in that type of container. Okay, and just like you have mentioned. Okay, very good. Good job. Let's see how we can explain this further. So the particles in gases are very far from each other. That is correct. You guys mentioned that. As you can see in the picture, each gas is on its own, each molecule is on its own. They are moving farther away from each other in different directions. They move quickly in all directions, so they spread out. Okay, they always spread out. Also, if squeezed in a closed container, they move closer together, just like you guys mentioned. So good job on this one. You guys nailed it. All right, any questions? Do you have questions for me on this one? Those whose hands are up, do you have questions? Mary, do you have a question?
Yes. Teacher.
Please.
What if I say that gases move at a high velocity until they collide with each other?
That is 100% correct, Mary. That's another property of gases that we see. They move in a very high velocity. High velocity means high speed, okay? For those who don't know the term velocity, means high speed in a certain direction. So they do move at a very high speed until they collide with each other or a container in which they are contained, okay? Mary, that is correct. You'd be correct if you said that. Ronald, did you have a question?
Yes, but if I say gases have very...
I didn't hear the last part.
Forces of attraction because the particles are far apart.
Yes.
What if I say particles of a gases when squeezed move closer to each other because they are far from one another?
That would be also correct. They are far apart because they have very, very weak forces of attraction. That's good. Good job. Naomi, do you have a question?
What if I say the kinetic energy of the molecule is greater than the attractive force between them? Attraction force between them.
Kinetic energy also means the force that causes motion. So the forces that cause motion in these molecules is very high that it overcomes or it defeats the intermolecular forces of attraction. And that's why gas molecules spread apart. So you would be correct also using that term. Okay, good job. Those were very, very informed questions. Good job, everyone. We can continue. Someone's baby is crying, serious. Please mute your volume. I think it is taking a... Okay, let's continue. I've tried to mute those who have unmuted. Yeah, remember those who haven't registered their name and contact in the chat box, please do that. George, you are correct by saying particles are far apart from each other in the chat box. Good job. So those are the particles in gases. This is how they behave. So good on you on explaining these. All right, I have something here. Here, we're just trying to investigate the evidence of gases having particles, okay? So this is what you do. You blow up a balloon, tie the string tightly around the neck, just like you do on Christmas and your birthdays. And then look at the balloon every day to see if it has changed size. Now, if you can access these balloons, I would say that you try this out, and maybe when you subscribe to Yaka, you'll tell me in the next chemistry class once you've subscribed, because like I told you, this is our last chemistry class. So once you subscribe, you'll tell me what happened. But here is a chance for you to tell me what you think before even you cut out the experiment. What do you think is going to happen to this balloon that you have inflated? I think the host wants to say something. His hand is up. Yes, host.
Okay, thank you, Teacher Solomon, for taking us through chemistry. I also enjoyed the lesson. I'm very attentive.
Oh, it is still going on.
Yes. So meanwhile, colleagues, we have English lesson immediate after chemistry. Then more to that, we shouldn't miss the session that we have tomorrow. We have a guest speaker. All of us should be there. And then also on Thursday, we have another session on how to effectively search the internet. We shouldn't miss all these sessions. More to that, remember to put your names and contacts in the chat section. Continue.
Very good job. All right. Kelvin, mute you for you. So thank you for that information. You guys remember that. Check in your WhatsApp group. The information is there, what the host has mentioned. Okay, please make sure you attend. It is important. You learn how to search the internet and you learn also other things. Okay. So again, I was asking a question. Once you blow up this balloon and keep it, what do you think is going to happen to it? What do you think is going to happen to its size? What do you think is going to happen to its size? Yes, Laura?
I think it's going to reduce in size because the air particles are small enough to escape through the holes in the balloon skin.
Okay, that is very, very correct. Is there anyone with a different idea? Nadia, do you have a different idea? Okay. Kyle, do you have a different idea?
Yes. I think that when you blow air to a balloon, that it's going to expand before the particles escape through the skin.
Okay, that's good. But what happens when you keep it for a couple of days? So what happens is what Laura mentioned, okay? And we're going to see the explanation after the host says this information. Yes, host? The host's hand is up.
No, very sorry, the hand remained up. I'm also stubborn. Sorry.
Jacob, did you have a question? I saw your hand up momentarily.
I
Yes,
wanted to
Jacob?
say something.
Yes, please do.
Okay, when you blow a balloon and when it is kept for a long time, as the particles in that balloon keep on moving because they are gases and those particles are always in random motion. As they keep on moving, they'll collide with the walls of the balloon. And when they collide with the walls, they are very, very tiny. So they will escape out and the balloon will keep on reducing in size.
Okay, that is very, very correct. Well done. Good job. Good job. That's a very good explanation. So you guys are very, very correct. So Laura and Jake, I don't know if that was Jacob, that is someone else. But you're very, very correct. Are you called Jacob?
It's my brother's name.
Yeah, so what's your name?
I'm called Joshua.
You're called who?
I'm called Jehosheba.
Oh, okay.
Sheba.
Sheba.
Yes.
Okay, now that one is easier. I was just going to say okay without repeating your name because it was very long, but Sheba is shorter. So, all right, good job, Sheba. That is very, very correct. These particles, like Sheba said and Laura, they'll keep in random continuous motion, but as they do that, they'll keep knocking on the walls of the balloon. As they knock, they will find these holes, as this hole here in the balloon. These are very, very tiny holes in the balloon that you can't even see them with your own eyes. You can't, but they are there because balloons are made up of rubber and rubber is not as compact as other solids, okay? So as they move randomly, they will hit these walls, and once they're on this wall, they can easily escape out, okay? Like this particle here, like this one here, okay? So they will escape out. This will continuously happen until the pressure in here in the balloon, all right? The pressure in here decreases. So as the days go on, you'll see that your balloon that you inflated a few days ago is decreasing in its pressure. That shows that gases are made up of particles, and these particles can easily escape from the balloon. Now, if you think that this is not true or you'd love to prove it further, go ahead. Just get a balloon and you do it, you'll see. So when you come back after subscribing for the next lesson next week, you'll see, you'll tell us that, oh, you guys were very, very correct. I proved this one, right? So good job, everyone. That was very, very interesting and very well done to all of you. Is there any questions that you have for me before we conclude? Those who have not registered yet, please do. Kyle, you have a question? Techno WX3P, you have a question? Your hand is up. Okay. If you have a question, can type it in the chat box.
Could you please send me your email?
Okay, my email will be sent to you in the WhatsApp group. For those who have not registered in the chat, please do. So well done, all of you, for today's lesson. My last message to you is this. You are really, really very active. Today we had a record-breaking attendance. About 55, 56 of you attended, which is great. And I would love to encourage all of you First, attend the sessions that the host talked about tomorrow and on Thursday. Make sure you attend them. The information will be in the WhatsApp group on how to attend. Okay. Secondly, I want again to encourage you to tell your parents to subscribe to Yaka. Okay, Yaka is a continuous platform. It doesn't matter whether school's open or not. For us, we continue doing our work. Okay. When you come back in the holiday, we still teach you on Zoom. You access teachers all the time. When you're at school and your lab, computer lab has internet, you can access the work on our websites. You can access assignments. You can even talk to our teachers, okay, on emails and other platforms and all that. Okay, so please encourage your parents to subscribe you on Yaka. And then we can continue with this wonderful relationship. I don't want to miss any of you because you guys are very active. I enjoy facilitating your learning because you are really, really active and you take everything serious. And you're very, very smart students. So I would really, really love to see you again in these lessons. Okay, good job today. I'm proud of all of you. Enjoy the rest of the evening. Those who are registering, please do before we leave. Those who haven't registered. But well done for today. Good job. Miracle says, thank you, teacher. You're a great teacher. Thank you, Miracle. You're a great student too. Thank you for participating. Hey, good job today, everyone. Thank you all for participating. Good job. See you soon next week once you've subscribed. I'll see you then. Bye-bye.